developed in France in the 1750s, and there are two main types: double housing and open side. Double housing planers have vertical supports along both sides of the bed where the metal lies. This helps to keep it firmly in position, but limits the size of the metal sheet that can be cut. Open-sided planers, however, can be used to cut much larger metal sheets because they don't have these supports, but in turn lose an element of stability and need more skill to produce the desired outcome. Number 9. Bending machine. Bending machines are, as the name would suggest, the way that pieces of metal are bent into the desired shape. Their development has meant that what once was a labor-intensive task can now be done much quicker, and the shapes that are made are exactly the same each time. There are several different types, but each works on the same principle. The machine is able to exert the pressure needed to bend the metal into shape, and very little human involvement is required. Bending machines are usually modular, which means that they are relatively cheap to buy in the first place, and operators can add additional functionality over time. Often, specific tools are used to create particular bends, so a U-bend attachment can be added to make a precise U-bend. An offset bending tool is used to create two bends with a gap between them. And there's a whole range of other options. Underpinning the whole process is bespoke computer software which calculates the exact forces required based on the thickness of the material and the type of bend being made. Number 8. Rolling mill. Rolling mills are hand-powered machines that are usually seen in small jeweler workshops. They have steel rollers that are operated by a handle and will change the gauge and shape of the metal being passed through it. This can, for example, be used to change a circular piece of metal into an oval one and is ideal for working on intricate custom designs. Having the thickness of a piece of metal will almost double its length, but it won't happen instantly. It'll need to be passed through the mill a few times, but once it's complete, it'll also be compressed and will be tougher for its size than when it started. Some mills also add the option to roll wires into various shapes, which are further useful to create shape defects. Without needing vast electronic machinery, rolling mills have made it much easier for smaller enterprises to create products, and they are fun to use too. Number 7. Steel punching machine. If you have a sheet of steel that you need holes or imprints put into, then a steel punching machine is your best bet. They're used for quick and efficient operations and are much more precise than if the work was to be done by hand with a drill. There's a wide variety of different versions of punching machines, some of which require an operator to manually position the steel before triggering the mechanism, and others which are fully automated and simply need the steel to be placed in before the computer software calculates what to do next. As not all jobs require the same hole to be punched a number of times, most machines will have a revolving turret or rail that contains dies of different shapes and sizes, so they can easily be switched to punch whatever is needed. Punching is the most cost-effective way of making holes in sheet metal and is essentially the same thing you do at home with a hole punch, but with a greater deal of force. Number 6. Metal laser cutting machine. Metal is a material that's used because of its strength, but this can be a problem when manufacturers need to cut specific shapes into it for a project. Luckily, there's a precise solution to this: a laser cutting machine. At first, these were only really used in large-scale operations, but they're now affordable enough for schools, smaller companies, and even at-home hobbyists. While there are a variety of different types of lasers that can be used, the most common one for metalwork is the CO2 laser. It's the highest powered type of continuous laser that you can get, and produce a beam of infrared light that cuts through material. Usually, a laser cutting machine will work by placing the entire sheet you want to cut onto a platform, and the laser will move around and cut the required parts. All of this is controlled by a computer that's already calculated where the laser needs to cut, and it's an extremely precise method. There are other versions, however, where the cutting head remains stationary and the material is moved around beneath it, and depending on how complex the cuts you need are, there are some that work on 5 or 6 different axes. Number 5. Honing machine. Once you've created an object from metal, you want to make sure the surface is as smooth as possible before applying any coatings to it. This is where a metal honing machine comes in. They're often used for cylinders to be used in engines, or for spindles and gears, and involve holding an abrasive stone on the metal and moving it along a prescribed path. This makes honing somewhat different from grinding because it offers a much more precise finish on the metal. Some machines have the option to focus on one part of the piece more than another, which will result in a different quality in the metal throughout the same object. In engines, this is useful because some parts are needed to glide more smoothly than others, and a crosshatch pattern is used on parts like pistons and brake rotors that help oil and grease remain on them so they're properly lubricated. Honing is seen as a precise process and is relatively expensive, so is only used for tasks where such accuracy is vital. With that said, it can improve metal components of most things, so if it's cost efficient, it's definitely worth doing. Before we move on, be sure to subscribe to Top 5s with notifications on. Number 4. Boring machine. Often, manufacturers will need to create large holes within the metal that they're working with, but it's not always so easy as putting it in one machine and everything done there. Boring machines are used once an initial hole has been cut, and they precisely widen and reshape the hole however needed. They're used to give a much higher level of accuracy than a machine that makes an initial hole can do, and can also be used to create a tapering hole. The machines come in two categories: generalized ones like lathes or milling machines, which are for multi-purpose work, or more specific ones like horizontal borers that are heavy-duty industrial machines for particular tasks like roughing out large components, or working on materials that can't fit in a normal boring machine. Number 3. Cold forging machine. Forging is the process by which you can turn metal from its natural shape into the specific shape that you want. There are two ways to do this: hot forging, which involves heating the metal to temperatures of up to 2100 degrees Fahrenheit, and cold forging, that does the process at room temperature. By cold forging, you're reshaping the metal below the temperature of its recrystallization point, and is a much more cost-effective way of reshaping softer metals like aluminum. The machines are also a lot easier to use because they don't involve potentially dangerous temperatures for the operators, and can help with further cost reductions because the finished product won't need finishing to the same degree as hot forged metal, and it also significantly reduces the risk of introducing contaminants to the metal. Number 2. Gear hobbing machine. A gear hobbing machine is a specific type of milling machine that is used to produce gears, splines, and sprockets. Starting with a flat cylindrical piece of metal, a specialized cutting tool called a hob is used to gradually carve out the teeth or splines that are needed on the final piece. The metal is held in place on a spindle, and another spindle holds the hob at a preset angle against it. The shafts are turned at a proportional ratio, which determines how many grooves are cut and how deep they go. Usually, multiple blanks are put into the machine at once, and it will cut them all at the same time to increase output. It's a relatively cheap way of making fairly accurate gears, and it's the most common type of machine that's used in their production. Various adaptations can be made to create gears for any use, and the introduction of these machines has vastly reduced the cost of the final product. Number 1. Die casting machine. Metal is an incredibly useful material, but there are a lot of objects that can't simply be made by cutting or bending sheets of it. In these cases, die casting machines are used where the metal is heated until it becomes a liquid and is then poured into a mold and allowed to cool. The result is a perfectly shaped object, and it will be virtually identical to every other one that has come from the mold or die. Most die casting machines are hydraulically powered. At first, the pistons of the machine pulls back, which allows the gooseneck to fill with molten metal, and then the piston is pushed forward, which forces the metal into the die. When running at full capacity, these machines can turn out thousands of objects in a day, and can be used with metals that melt at low temperatures like zinc, tin, and lead-based alloys. Subscribe to Top 5s for more and check out some of our other popular videos.